Hello class, today we are starting chapter 7, which is going to focus on the concept of polynomials. Today we are going to start by multiplying the monomials, which is section 7.1. So by the end of today you will be able to identify what a monomial is and use the product rules of exponents to simplify the expression. So a monomial is one of three things. First, it can be a number. So any number that you can think of, fraction, decimal, whole number, negative, positive, anything that you can think of as a number is going to work as a monomial. Second, it could be a variable, so just any letter standing by itself, x, a, m, whatever your variable so happens to be. If it's standing alone, it is a monomial. And the last thing we can have is the product of a number and variables as long as the variables have whole number exponents. So if I have a to the second power, that is fine. If I have a to the 1/2 power, that is not okay. Few things that are not allowed: no negative exponents, no variables in the denominator of an expression, and one more that I should add in: no adding or subtracting. So there's no addition or subtraction allowed in a monomial. It is just a single thing. A constant is a specific name we give a monomial if it is just a number. So in the number case, we would call it just a constant. So part of your homework is going to be identifying monomials. So we're going to go through and talk about these 9 different expressions and decide if they are or are not. So this first one, we have x, y, z squared divided by 2. So we're going to go through and check. We've got numbers and variables involved. And then we need to check our 3 no's. So is there a negative exponent? There's a positive exponent, so it's not ruled out yet. Are we dividing by a variable? No. And then is there any addition or subtraction? No. So this is, yes, a monomial. Then we're going to bump over to this second one. I've got MP divided by N. We do not have any negative exponents. However, we do have division by a variable. So this is not a monomial. The next one we're looking at is just a number. So that is, yes, a monomial. Next one, we've got multiplication with numbers and variables. So now we want to check our 3 rules. Our exponent is not negative, we're not dividing by a variable, and there's no addition or subtraction. So this is, yes, a monomial. The next one, we've just got a variable with a positive exponent, so it's yes. Our next one, we've got addition involved, so we're going to toss that out, not a monomial. Variable by itself is a monomial. Addition tosses it out again, and then we're back to exponents and division. There is no negative exponents, and we're dividing by a number instead of a variable. So this one is, yes, a monomial. If you have questions about what a monomial is, please let me know when you get to class. One of our rules when we are looking at monomials and powers is that if we multiply 2 powers with the same base, we're going to add their exponents. So we've got our 2 different powers down here, both of them with a base of b. If we revert back to what it means to have an exponent, this first term is telling us that I have b times b times b. That's what the exponent of 3 means. And the second one is b times b times b times b times b. Now, we are multiplying those 2 together, which means we actually have 8 b's being multiplied. If we look at our exponents here, 3 plus 5 is equal to 8. So that is why this rule works, because we are just multiplying over and over. So we can add up and say that we are multiplying b 8 different times. So if we look at something a little bit more complex, when we start to put numbers in front, we're going to want to deal with the numbers first. So I've got 3 and 7. Those are being multiplied. 3 times 7 gives me 21. Then I've got y to the 4th times y to the 5th. Following our product rule, we're going to get y to the 9th. Adding up 4 and 5 gives me 9. Again, taking it even a step further, adding in more variables, We're still going to start by multiplying our numbers. So -4 times -6 gives me 24. Then I'm going to go through and do each variable individually. So I've got r and r to the 5th. If a variable is standing alone by itself, like this r is, you can always tuck in an exponent of 1. There's only a single variable, so you don't have to write the exponent in, but it might be helpful because you do need to add 1 plus 5 to give you a total of 6 r's. Then we're looking at the x's. I've got x squared and x squared, which is x to the 4th. And the last part is d to the 3rd, and d, again, you can write in that variable, or excuse me, that exponent of 1 on the variable, and you have a total of d to the 4th when you are multiplying. So be careful with those individual variables that you don't leave them out of your count when you are doing addition with your exponents. Go ahead and try this one on your own. -5 times 7 is -35. 4 plus 6 gives us a to the 10th. And 12 plus 2 gives us b to the 14th. If you have questions about the product of powers rule, please let me know when you get to class. Our next rule is the power of a power rule. So that's saying when a power is raised to another power, we are going to go ahead and multiply those exponents. So breaking it down with this example, we have b to the 3rd, and we have that 5 times. So what this is saying is I've got b to the 3rd times 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 b to the 3rd. So I've got b to the 3rd 5 separate times. If I break down each of those, I've got 3 b's from each of those terms being multiplied. And if I were to add all of those up, that would give me b to the 15th power. So instead of writing out these expressions the long way every time, we can multiply. So a couple of things to help keep this straight for you. If we look back at this example, a was listed twice, and that is when we added the exponent. Right here, our b is just listed once, but we have 2 separate exponents going with the b. That is when you're going to want to multiply. So we've got 7 to the 3rd power raised to the 8th power, which means that we've got 8 times 3, giving us 7 to the 24th power. This one has it layered even more. We've got a power raised to a power raised to a power. So we're going to start on the inside part. 2 to the 2nd power to the 2nd power gives me 2 to the 4th power. And we still want to take that to the 4th power. So now I'm going to take the 4 to the 4th power, and that's going to give me 2 to the 16th power. So we can layer these up even more than just raising a power to a power. You can keep having parentheses or brackets and still follow the same rule. Go ahead and try this one on your own. So first we dealt with the 3 times 5, which gave us the 15. Then I've got 15 to the 2nd power, which gives us 3 to the 30th power for our final answer. If you have questions about that, please let me know when you get to class. The last thing we have is the power of a product rule. So this is to find a power when there are multiple bases. We have to raise each of those bases to that power. So this is kind of like our distributive property of exponents. We have things being multiplied inside the parentheses. This is -2 times x times y to the 3rd. And that whole expression is being raised to the 5th power. So again, if I broke this down, it'd be -2 x y to the 3rd, and that would be written out 5 separate times. So we've got it written out 5 separate times. Then we would have to follow our product rule, so multiplying -2 times -2 times -2 times -2 times -2, which would give me -2 to the 5th power. Right now our -2 had an exponent of 1, so if I multiplied 1 times 5, distributed that 5 in, I would get -2 to the 5th power. Then again, I would have x times x times x times x times x. So I would have x to the 5th power. Again, there was a 1 there to start, so 1 times 5 gives us to the 5th power. And the last one is I've got y to the 3rd, y to the 3rd, y to the 3rd, y to the 3rd, and y to the 3rd. If we follow the power of a power rule, that's going to give us y to the 15th, or 3 times 5. So that 5 is being distributed to each of the 3 powers on our original terms, giving us that final answer of negative 2 to the 5th, x to the 5th, and y to the 15th. So if we are applying that to a word problem, it's asking us to express the area of a square with side length 3xy squared as a monomial. So if you remember the area formula for a square, area is equal to our side squared. Well, we know that our side is 3xy squared, so I've got my area is equal to 3xy squared squared. So I'm going to take and I'm going to use that distributive property of exponents, and I'm going to bring that into each term. So now I've got my area is equal to 3 squared, x squared, and y to the 4th. If I wanted to go ahead and finish simplifying, I could say a is equal to 9x squared, y to the 4th. So I can solve that actual numerical part of the problem. Go ahead and try this one on your own, distributing the exponent to each piece. So I've got 4 to the 4th, h to the 12th, j to the 4th, and k to the 8th. If you finish that simplification, you have 256 h to the 12th, j to the 4th, k to the 8th. If you have questions about that, please let me know when you get to class. Last thing we want to talk about is making sure that we have our expressions simplified as far as possible. There are 3 rules to this. First, each variable appears exactly once. So if you see a variable listed twice, you're going to want to go back and use that product of powers rule where we are adding them up. Then we have no powers of powers, so we're going to use the power of power rule, or potentially that distributive property rule, that product of powers rule, to help us get rid of that. And then if there are any fractions, we want to make sure that those are simplified. In the same line of that, you want to solve all numerical exponents. So if you have, for example, 3 to the 3rd power, you're going to want to use the number 27 as opposed to 3 to the 3rd power. We've got 3xy to the 4th, and then in brackets we've got negative 2y squared to the 3rd power. When you are simplifying, you want to start with the more complex piece first. So we're looking at this second piece. Start as far inside the parentheses as you can. So we're going to look at this inner part first. So I've got negative 2y raised to the 2nd power. So I'm just going to go ahead and copy this first part, since I haven't done anything to modify that yet. And inside now, I've got negative 2 to the 2nd power and y to the 2nd power. And that expression is still being raised to the 3rd power. So if I can simplify anything in here, which I can solve that numerical exponent. So I'm going to go ahead and say that 3xy to the 4th is, when I simplify, 4y to the 2nd to the 3rd power. Then again, this second piece is still our more complex part because we still have a power on the outside. So I'm going to leave this first part again, 3xy to the 4th. And now I'm going to multiply that. I'm going to bring in my exponent. So I've got 4 to the 3rd and y to the 6th. Because I am doing a power of power, I've got 2 times 3, which is 6. Again, I'm going to want to simplify. So I've got 4 to the 3rd power, which is going to be 4 times 4 times 4, which gives me 64. So I've got our expression of 3xy to the 4th times 64y to the 6th. Then I'm going to go through and finish the problem. I'm going to multiply my numbers out front, and I've got 3 times 64, which is 192. There is nothing to match the x with, so we've just got x. And our y variable is listed twice, so I've got 4 y's being multiplied and 6 y's being multiplied for a total of 10 y's being multiplied. So our final answer for the simplification is 192xy to the 10th power. Go ahead and try this one on your own. First steps is going to be to distribute those squared or those exponents of 2 into both expressions. So I've got 4 to the second, a to the second, b to the 10th, negative 3 to the second, a to the second, c to the second. Simplifying those number parts down, I've got 16 and 9. Then I'm going to want to go ahead and combine my variables where I can. So I've got 16 times 9, which is 144. A to the second, and a to the second is a to the fourth. B to the 10th had nothing to pair up with, so it's b to the 10th. And c to the second had nothing to pair up with, so it stays as c to the second. If you have questions about this or anything else from the lesson, please let me know when you get to class.